everyone, this video is about the Sharp G850V, which came on the market in Japan in 2001. And the 850 was the last pocket computer Sharp made, and as far as I know it was the last pocket computer made by any electronics manufacturer. And Sharp really pioneers the form factor with the PC-G850V, released 21 years earlier in 1980, which was sold in the US under the Tandy brand as the TRS-80 PC-1. And Sharp went on to create over 100 models of pocket computers over the following 2 decades. And in function and price, they always filled the gap between programmable calculators and desktop computers. And in the Japanese market in particular, this made them very attractive for the education market. And like the Casio VX4, which I have a separate video on, the 850 was most likely designed for students, but it had some more powerful features than the VX4. In particular, as well as supporting BASIC and C programs, the 850 also supports 3 different assemblers. One for its native Z80 machine code, another for the CASL assembly language for the Comet virtual machine, and yet another for programmable PIC microcontrollers, which the 850 could interface with via a special port. And unlike many Japanese pocket computers, there is excellent documentation available for the 850 in English and German, created by the community. And the English user manual in its 3rd version now, written by Jack W. Sue, is really comprehensive and helpful. So physically the 850 is quite large at just under 20 by 10 centimeters, and it weighs 260 grams with batteries. It has a 48 by 144 pixel screen that can display 6 lines of 24 characters. On its left side is a 11-pin PIO interface for 8-bit control of PIC microcontrollers. And on its right side is a 11-pin RS-232C port that supports printer and tape driver. The 850 also has a power port that takes 4 AAA batteries. The device is powered by a CMOS Z80 8-bit processor that runs at 8 MHz, and it has a 256K ROM, which, as we will see, does pack in a lot of functionality, and it also has 32K of RAM that can be used as a RAM disk, and I'll demo that later. The 850 also comes with a rigid plastic cover. The 850 supports a simple calculation mode that acts like a 10-digit calculator, and to use this the computer must be set to basic run modes. So here I can enter equations and hit enter. And I can hit the left arrow key to edit. And I can also use the answer key to refer to previous results. And in calculation mode you get access to a lot of built-in functions, but sometimes this is a bit quirky. So for example, I can type in sine of 45, but then if I hit the sine button again, it gets applied postfix to the previous answer. And unfortunately, like other Casio and Sharp pocket computers, you can't call user-defined functions from calc mode. But the 850 also supports a number of built-in programs. So for example, there's a base conversion program that can be accessed via shift and right parentheses. And this loads a program into basic memory and runs it. And the UI for this, like a similar program for statistics, is in Japanese, but the English manual does explain the meanings of the options. So for example, I can hit or enter a value using option 1, and then convert it to hex using option 2. And it's interesting that a few of these modules are in Japanese, since the core UI of the 850 is all in English. And you can use the shift and caps lock keys to enable Japanese character input. And the 850 has relatively advanced basic language, not dissimilar to the Casio VX4. But one notable improvement is that it supports text labels, which is really helpful to make subroutine calls more understandable. And the 850 also supports reading and writing programs from a RAM disk, and this works via the text editor function. So to demo this, I'll go into the text menu and then I'll load a file. And so I'll pick my nqueens basic program. And once we've done this, we can hit edit to view it. And the code is almost identical to the VX4 version, but I have gone through and defined labels for all goTo and goSub statements to refer to. And so to run it, we first need to transfer the program from the text editor into basic memory. And once we've done this, we can switch to basic mode. And the basic button on the 850 switches between program mode and run mode. So in program mode, we can list the function and we'll see the nqueen solution. And we can go back to run mode to execute the program. And so 8 queens takes around 45 seconds to complete on the 850, and so I'll skip now to the finish. And the 850 also supports a C compiler that produces code that runs significantly faster than BASIC. So I'll load up my C version of nqueens. And we can open that in the text editor. And you'll notice immediately that the code has line numbers in it, and apparently they are just required for the 850's editor, which is a little bit of a shame. But like the VX4, the 850 supports a pretty robust implementation of C, and also like the VX4, there are no inputs required, and many standard functions are just available to programs. And so once the C file is in the text editor, we can switch to the C language menu and hit compile, and that compiled pretty quickly. So now we can hit go to run the code. As you can see, the code runs pretty swiftly, around 4 times faster than the basic version. And this version finds the first solution to 8 queens in around 12 seconds. And I'll include a link in the video description to a table of benchmarks using 8 queen solutions on other calculators. And the assembler function of the 850 is particularly nice because it supports 3 architectures. The first is the Z80 Assembler, which produces machine code that runs natively on the 850's processor. And to use the Z80 Assembler, we first need to run the machine language monitor from basic mode. And here we'll need to allocate a memory area for machine code. Now once we've done that, we can load Z80 Assembler version of nqueens, which I found on the HP Museum site. And you can see even assembly language programs require line numbers. And so now we can go into our assembler function and run the assembler. And now we can switch back to our machine language monitor and take a look at the output. So there's a bunch of native instructions here. And then at 0150 hex address, there's a 9-byte array allocated for the output. So we can go back and actually run the code now. And interestingly, this takes around 45 seconds to run. And I'm not sure why it's slower than the C version. It may be because it's running under the monitor. But I'll skip to the end now. The program's finished now, and we can dump memory to look at the output. And so you can see that the solution it came up with is queens at ranks 8, 4, 1, 3, 6, 2, 7 and 5. And as you can see, this produces a board with a bunch of queens that don't share a rank, file or diagonal. And the CASL and PIC assemblers work in a very similar way. CASL was an abstract virtual machine with a simple instruction set designed to teach students about low-level programming. And also include a link in the description to another video that shows PIC code being assembled on the 850 and loaded into a separate microcontroller. And so in summary, the Sharp G850V is a really flexible device, and being the final evolution of 20 years of Sharp pocket computers, it really shows a level of product maturity. But it isn't without its quirks, in particular its dependence on line numbers and source code. It's also to be noted that while having 6 lines of text is great for programming, only being able to view 26 characters on a line is quite limiting if you're programming in BASIC or C. Even though the basic implementation is relatively advanced, it doesn't support local variables or calling functions from calculator mode, which was a key feature of, say, the HP 71B device from much earlier in 1984. But I think if you want to tinker with C or assembler, the 850 is a really great option. In some ways it's sad that this was the last of the form factor of pocket computers. As I mentioned in other videos, there's something really appealing about a programmable handheld device with a QWERTY keyboard, and many professional software engineers learned to code on these devices, especially in the 80s, and remember them fondly. Anyway, I hope you enjoyed this video and found it useful. If you did, don't forget to subscribe to the channel and hit the notification bell to be alerted of new videos.